Hello everyone, welcome back to my YouTube channel. So today in this video, we'll be discussing about the power of a lens. So this topic is there in class 10 as well as class 12. So you may get numericals based on this, which will be objective type numericals. So you can easily score marks here. So for that you need to understand few concepts. So the first thing is you have to understand what is a power of a lens definition. So we have discussed about two types of lenses, that is convex lens or biconvex lens, which is also called as the converging lens, and a concave lens, which is also called as the diverging lens. So whenever rays of light fall parallel to the convex lens or the concave lens, it has the ability to diverge or converge it. So this ability of the lens to either converge or diverge the parallel rays falling on it is called as the power of a lens. Mathematically, we can define power of a lens as the reciprocal of its focal length, which is measured in meters. Alright, so here you can see, so power of a lens, the formula based on which you will get the numerical, P is equals to 1 divided by F, where P stands for power of the lens. It can be concave lens or a convex lens, and F stands for focal length of the lens in meters. Whenever you have to measure the power, focal length has to be in meters. Now, in order to find the power, you may need the sign convention for the focal length. So here I have shown you the diagram for a concave lens, and here I have shown you convex lens. So for a concave lens, if the rays fall parallel to the principal axis, then it gets diverged. And when you produce these rays backwards, it will intersect a point which is called as the focus. And this focus lies to the left of the optical center. So this length or distance between the optical center and the focus, we call it as the focal length. And since it is to the left, focal length will be negative for a concave lens or a diverging lens. Similarly, here you can see we have parallel rays falling on a convex lens. And when parallel rays fall on the convex lens, it converges or meets at a point which is called as the focus. So this distance again between the optical center and the focus, we call it as the focal length, and since it is to the right, the focal length is positive. So I have intentionally drawn concave lens to the left and convex lens to the right so that it can indicate the sign convention for focal length. Focal length for concave lens, negative, it is towards the length, and focal length of the convex lens is towards right, so it will be positive. Now the other thing that they might ask you is the unit. The SI unit for the power of a lens is diopter, or you can also write it as meter inverse. Okay, so meter inverse or diopter is the SI unit for the power of a lens. Okay, so let's discuss this first question, which is a simple question, numerical question. The question says, a convex lens is a focal length 10 centimeter. What is its power? So focal length of a convex lens is given. You have to calculate the power. So let's do this. So the first thing that you will write is the given. So given is the focal length, which is represented by small letter f. So you can see focal length, the value is 10 centimeter. Now here you have to see what kind of lens are they talking about. So they are talking about a convex lens. Now for convex lens, the sign convention for the focal length will be positive. So this is very important. You have to use the sign convention. So convex lens, focal length will be positive. The value given is 10 centimeter. You have to calculate the power. So power you have to find out. Now we know the formula for calculating power is P is equals to 1 divided by F. So put the value. So it will be plus 10 centimeter. Now remember, in order to calculate the power, the focal length has to be in terms of meters. But the given value is in centimeter. So you have to convert this centimeter into meter first. So let's do that. So P is equals to 1 divided by, so plus 10 centimeter is nothing but 1 divided by 100. So if you don't know, then 1 meter is equals to 100 centimeter. So if you cross multiply, 1 divided by 100 meter will be equal to 1 centimeter. So this 1 centimeter can be written as 1 divided by 100 meter. That's what we have done here. Centimeter, we have written 1 divided by 100 meter. So this 0 and this 0 can be cancelled. This 10 goes to the numerator. So you'll get P is equals to plus, don't forget the sign convention, plus is there. So this 10 goes to the numerator. this meter goes to the numerator, the sign of the power will change. Whenever certain term goes from numerator to denominator or denominator to numerator, then the sign of the power will always change. So this meter is in the denominator, you are taking it to the numerator. So when you take it to the numerator, plus 1 becomes minus 1. And this meter inverse 1 or meter to the power minus 1 is nothing but it is the SI unit for the power of a lens. So the answer for this question will be the power of the lens will be 10 diopter. Alright, sometimes other type of questions will also be added here, so we will discuss that in the other questions. Alright, so let's discuss this second question. Question says a thin lens has focal length of minus 25 centimeter. What is the power of the lens and what is its nature? So there are two questions that has been asked here. One is the power, the second thing is the nature. So let's do this. So the first thing that you have to write here is given. So the given term here is focal length, which is minus 25 centimeter. Now you need to calculate the power of the lens. So here we don't know what kind of lens is given, but if you look at the sign convention for the focal length, you already know the nature. So what kind of lens has focal length which is negative? It is a concave lens. So we'll write the answer at the end, but you don't have to do anything for this. You just have to see the sign convention for the focal length. Focal length is negative, means it is a concave lens. Alright, so let's calculate the power. So now we know power is 1 divided by focal length. So 1 divided by focal length is given as minus 25 centimeter. But centimeter has to be converted into meter. So 1 divided by minus 25. 1 centimeter is 1 divided by 100 meter. So if you take 100 to the numerator, it becomes P is equals to minus 100 divided by 25. This meter, you take it to the numerator, it becomes meter inverse. 25 1 times, 25 4 times. So you'll get power is equals to minus 4 meter inverse, or meter inverse is nothing but it is called as the diopter. So we have done what is the power of the lens. So this first part is answered. Now the second part is what is its nature. So as I said, you don't have to do anything here. You just look at the sign convention of the power as well as the focal length. So since the power and the focal length is negative, you can write it is a concave lens. So that's all. So you don't have to do anything. You just look at the sign convention and you can write the answer. If it is positive, if the focal length is positive, it will be a convex lens. If it is negative, then it will be a concave lens. So let's discuss the third question. This is slightly different from the first two. In this case, the question is a lens has a power of minus 2.5 diopter. So here, instead of focal length, power is given. What is the focal length and nature of the lens? Again, here you have to find two things. One, the focal length of the lens, and the second thing that you have to find is the nature, whether it is a concave lens or a convex lens. Alright, so let's do this. So the given term here is the power, and it is given as how much? Minus 2.5 diopter. Now diopter is nothing but meter inverse. So you can write this as meter to the power minus 1. Now focal length we have to find out. So we use the same formula. So we know power is 1 divided by focal length. So focal length will be 1 divided by power. Just do the cross multiplication. After that, put the value. 1 divided by power is minus 2.5 meter inverse. Now what you can do here is take meter inverse to the numerator. So it becomes 2.5 meter inverse. If you take it to the numerator, then it becomes meter, right? After that, what you can do is convert meter into centimeter. So focal length is equals to 1 meter will be equal to 100 centimeter divided by 2.5. So here we have used 1 meter equals to 100 centimeter. Now if you have problem solving with the decimal, then what you can do is you can remove the decimal. Then f is equals to minus 100 centimeter divided by 2.5 can be written as 25 divided by 10. So you can take this 10 to the numerator, so it becomes 10 into 100 centimeter divided by 25. So 25 1 times, 25 4 times. So if you multiply, you will get f is equals to minus 40 centimeter. So this is the first part of the answer. You have to calculate the focal length. So focal length for this lens will be minus 40 centimeter. Next is the nature of the lens. Now if you look at the focal length, it is coming negative. So what kind of lens do we have? So you can write it is a concave lens. So this is what you are supposed to find out. So if you are done with the first three questions, then I think you have an idea how to solve such questions. So I am leaving you with three more questions for practice. So here you can see the questions. The first question, a person having a myopic eye uses a concave lens of focal length 50 centimeter. What is the power of the lens? So in first question you just have to calculate the power. The answer I have given you here, it is minus 2 diopter. The second question, the power of a lens is minus 2.0 diopter. Find its focal length and its nature. So there are two questions, focal length and nature. So answer will be minus 50 centimeter. So this is the focal length and nature will be concave. And the third question, find the power of a concave lens of focal length 2 meter. Here the focal length is given in meter itself, so you don't have to convert it into meter. Alright, so answer will be 0.5 diopter. So you just practice these questions. If you are getting the answer, then it means that you have understood. So next we will discuss about the lenses in contact. So for that we have different formula. So I'll give you the formula and then we'll discuss some numericals based on that also. So now let's discuss when two lenses are kept in contact. So the two lenses that are kept in contact may be concave and convex or the similar type of lenses. So when we have such case, then how do we calculate the equivalent focal length and equivalent power? So the formula will be, for calculating the equivalent focal length, the formula will be 1 by f is equals to 1 by f1 plus 1 by f2, where f stands for the equivalent focal length, okay, the resultant focal length. F1, it will be the focal length of the first lens, it may be concave or convex, and similarly f2 will be the focal length of the second lens. So here you have two lenses that are kept in contact. Now if you have to calculate power, equivalent power of the two lenses that are kept in contact, then simply 1 by f is nothing but p, 1 by f1 is p1, 1 by f2 is p2. So the equivalent power p will be equal to p1 plus p2. That means you have to take the sum of the power of the two lenses that are kept in contact. So using this formula, now we can calculate the equivalent focal length and equivalent power of the two lenses which are kept in contact. Okay, so this is the first question for combination of lenses. So the question is, a concave lens of focal length 25 centimeter and a convex lens of focal length 20 centimeter are placed in contact with each other. So we have two lenses, concave and convex. So what is the power of this combination? And also calculate the focal length of the combination. So we have two lenses that are kept in contact. One is concave, another one is convex. So the question is, you have to find the equivalent power and equivalent focal length. So let's do this. So let's write the given terms first. So the first one is concave lens and its focal length is 25 centimeter. So let's write it as f1. So the value is 25 centimeter and this is what kind of lens? This is a concave lens. And another one is a convex lens and its focal length is 20 centimeter. So let's write it as f2 and this is 20 centimeter. So this one is our convex lens. Now what we have to find out is power and the focal length of this combination. Now before we do anything, we have to use the sign convention for the focal length. So concave, it will have negative focal length, convex, it will have positive focal length. So this step is very, very important. Now let's first calculate the equivalent focal length and then we can calculate the power. So the question is to find the equivalent focal length and we have to find the equivalent power. Now we know the formula for calculating the equivalent focal length. So it is 1 by f equals to 1 by f1 plus 1 by f2. So you put the value of f1 and f2 along with the sign. Or 1 by f is equals to 1 divided by f1, it is minus 25, plus f2, it is plus 20. So this becomes 1 divided by 20. So you can write this as 1 by f is equals to minus 1 by 25 plus 1 divided by 20. Now take the LCM. So LCM of 25 and 20 will be 100 So 25, 4 times is 100. So we have minus sign here. So 25, 4 times is 100 plus 25 times is 100. So here you will get minus 4 plus 5. This will give you plus 1. So 1 divided by 100. So if you take the reciprocal or if you cross multiply, you will get F is equals to 100. Remember the unit here is centimeter. So it will be centimeter. So the equivalent focal length will be 100 centimeter. Calculate the equivalent power. So power, we know the formula is 1 divided by F. So F we have got 100 centimeter. So this 100 centimeter is nothing but we can write this as 1 meter. So if you take meter to the numerator, 1 divided by 1 will give you 1. Meter, if you take it to the numerator, it becomes meter inverse. And meter inverse is nothing but diopter. So the power of this combination will be 1 diopter and focal length will be 100 centimeter. So this is how you have to solve such questions. Alright, so let's discuss the second question. The question says a convergent lens of power 8 diopter is combined with a divergent lens of power minus 10 diopter. Calculate the focal length of the combination. So here they have not mentioned convex or concave, they have mentioned convergent and divergent. But you have to understand convergent means convex, divergent means concave. And we can also understand this from the given value. So let's solve this. So given we have power in this case. So power of convergent lens is 8 diopter. So 8 diopter. So this one is convergent, means this one is convex lens. And the power of the divergent lens with a divergent lens of power minus 10 diopter. So minus 10 diopter. This one is our concave. So what you have to do is you have to calculate the equivalent focal length or the total focal length of this combination. So we have to calculate the focal length F of this combination. So for that, what we will do is we will calculate the equivalent focal length first, equivalent power, and then we can easily calculate the focal length here. So we'll start with, so we know, here you don't have to use any sign convention because it is already given in the question. So we know equivalent power will be P1 plus P2. So you can see the value of P1 and P2, P is 8 and P2 is minus 10. So plus into minus becomes minus. So 8 minus 10 unit is diopter. So this will give us 8 minus 10 will give us minus 2 diopter, which can also be written as minus 2 meter. Okay. Now what we have to calculate is the equivalent focal length or the focal length of this combination. So the formula is F is equals to 1 divided by P, or F is equals to 1 divided by the power is minus 2 meter. So you can convert this meter into centimeter, or you can write this in meter also. So focal length will be 1 divided by minus 2 times 1 meter is 100 centimeter. Alright. So you will get focal length is equals to minus 1 divided by 200 centimeter. Alright, so here diopter, this one will be meter inverse. So we have to have meter inverse here. So this will be, you can write this as meter. If you take it to the numerator, then this becomes meter in the numerator. So let's change this. So 1 meter will be 100 centimeter divided by 2. So this will become 50. So therefore the answer for the focal length of the combination will be 50 centimeter. Alright, so let's discuss this third question, which is interesting. So the question says a concave lens is kept in contact with a convex lens of focal length 20 centimeter. The combination works as a converging lens of focal length 100 centimeter. Calculate the power of the concave lens. So here a concave lens is in contact with the convex lens. The focal length of convex lens is given. The focal length of the equivalent combination is given, but focal length of concave lens is not given in this case. So you are supposed to find out the focal length of the concave lens. So let's do this. So let's say F1 is the concave lens. So since its focal length is not given, let's write it as F1 only. So this one is our concave lens, and the focal length of the convex lens is given. So for focal length of convex lens is 20 centimeters. So we'll write the value here. So this one is our convex lens, and also the focal length of the combination is given, which is 100 centimeter. So that will be f is equals to 100 centimeter. So this is the focal length of the combination, and this combination works as a converging lens. Converging means a convex lens. So here you can write convex. So this equivalent or the combination of these two will work as a convex lens. So for concave lens, focal length will be negative if you use the sign convention. For convex lens, it will be positive. For convex lens, it will be positive. So we are supposed to find out the value of f1. So we'll use the formula. 1 by f is equals to 1 by f1 plus 1 by f2. So don't put the value here. First, rearrange this equation and keep f1 alone so that you can easily do the calculation. So what we will do is we'll bring 1 by f2 to the left hand side. So 1 by f plus becomes minus 1 by f2 is equals to 1 by f1. Now put the value with the sign and do the calculation. So 1 divided by the value of f is 100 centimeter. So 100 minus f2 is 20 centimeter. So 1 divided by 20 is equals to 1 divided by, we have f1. Now take the LCM. So LCM of 120 is 100. So 100, 1 time is 100, 20, 5 times is 20, 5 times is 100. So this will be equal to 1 divided by f1. Or you will get 6 divided by 100 is equals to 1 divided by f1. If you do the cross multiplication, then f1 will be equal to 100 divided by 6. Alright, so I hope we have done it correctly. So now you can divide this. It will give you how much? So this will be in centimeter itself. So f1 will be equal to, we will get 100 divided by 6. So 6, 1 is 6, 4066 is 36. Point. Let's check this again. So here we have 1 by f. So here we have to change this. Let's do this again. So here we have 1 by f minus 1 by f2 is equals to 1 by f1. So now put the value with the sign convention. So 1 divided by f, so it is 1 divided by 100, then minus 1 divided by, you have f2 is your 20 is equals to, we have f1 as minus f1, so minus of 1 by f1. So you are getting here LCM, it will be 100. So 100, 1 time is 100, 20, 5 times is 100, so minus 1 by f1. So this will give you minus 4 divided by 100 is equals to minus 1 by f1. So minus minus you can cancel. If you cross multiply, you'll get f1 is equals to 100 divided by 4, which will be equal to 25 centimeter. So we have obtained the value of f1 and it comes out to be 25 centimeter. Now the question they have asked is calculate the power of the concave lens. So this is the focal length of the concave lens. So now we need to calculate its power. So let's calculate the power. So the formula will be P is equals to 1 by f1, since f1 is the focal length of the concave lens. So P is equals to 1 divided by 25 centimeter, and since we are talking about concave lens, it will have a negative sign, so this is centimeter. Now you convert centimeter into meter, so 1 divided by minus 25, 1 centimeter is 1 divided by 100 meter. So you take this value to the numerator, so it becomes minus 100 divided by 25 meter inverse. So this will give you minus 4 meter inverse is your diameter. So the power of this concave lens will be equal to minus 4 diameter. So this is how it has to be done. Solve numericals based on the power of a lens and also the combination of the lenses. I am leaving you with one question. So the question says a convex lens of focal length 25 centimeter and a concave lens of focal length 10 cm are placed in contact with one another. So you have three questions here. What is the power of the combination? So you have to calculate the power. What is the focal length of the combination? And third one, is this combination converging or diverging? So I hope you can easily find out the power and the focal length of the combination. Now for this third one, whether the combination is converging or diverging, what you have to say is, if the equivalent focal length or the focal length of the combination comes out to be positive, that is f is positive, then the combination works as a converging, that is convex. But if f, that is the equivalent focal length, comes out negative, then the combination works as the concave. Alright, so you just have to see the sign of the equivalent focal length. If it is negative, then it will be diverging. If it is positive, then it will be converging. So that's all for today. I hope you have enjoyed this video, and I guess you have learned. So do like, share and subscribe, and I'll see you in the next video. Thank you everyone.